As a cybersecurity professional, it's important to focus on the digital side of security, but what about the physical side in terms of hardware? In order to have software running, we've got to have hardware that underlies that supports that as infrastructure. And so let's talk about securing hardware in a couple of different ways, such as limiting physical access to it in the first place. We know already that gaining access to a server room from a malicious user's perspective is a treasure trove. A lot of security controls can be bypassed by having physical access to a device. Of course, that can be mitigated by encrypting things like disks. Even if a malicious actor gets into a server room where the storage arrays are and physically steals disks and connects them to their home systems, if they're encrypted, they're probably not going to be able to crack the decryption key. They just don't have the compute power to do it or the time for that to occur. So having things like alarms and sensors physically for security into a facility, door locks, also making sure that cards aren't easily forged. I'm talking about common access cards or smart cards. You could also call them proximity cards. Whatever you want to call it, those can be forged. There are tools that anybody can buy on Amazon or eBay that allow you to create your own cards. And if you have a bit of knowledge on what is written on magnetic strips on the different tracks of the stripe, then you can actually get away with forging some types of cards. Now that's a lot harder now with chip cards, and that's why chip cards have become so popular. But anyways, that's another aspect of physical hardware we have to bear in mind. The other thing to think about is, let's say we want to have a bunch of firewall appliances, physical hardware firewall appliances that we plug in at different points on the network. If you get all of those devices from the same vendor, whether it's FortiGate or Cisco or Juniper Systems, if those devices are all configured in the same way and using the same firmware revision level and there's a vulnerability, then they're all potentially attack vectors. But if you start mixing up different vendor equipment, it can actually make it much more difficult for an attacker to penetrate a network. So that's another consideration, is diversity in vendor solutions. And then, of course, there's limiting the use of removable media, such as USB thumb drives. What we don't want is people plugging in USB thumb drives randomly from home that they brought into work and infecting the network, or perhaps, in a more nefarious sense, copying sensitive files to it and taking it outside of the organization. Now, what can we do about that? Let's take a look. Here in my Windows server, my goal is I want to limit how removable storage media can be used, if it can be used at all. In a Windows environment, we can set that up in group policy. If you have standalone computers, you can edit group policy on each one of them, but if the machines are joined to an Active Directory domain, you can make the group policy setting once to potentially affect every computer in the domain. Anyway, here in the Start menu, I'm going to type gpedit.msc. That stands for Group Policy Editor, and MSC stands for Microsoft Console. It's built into the Windows OS. I didn't make that. So I'm just going to go ahead and select that from the Start menu. So Group Policy literally consists of thousands of settings. Not all of them are security-based, but there are quite a few. So what I want to go to is I want to drill down under Computer Configuration on the left, Administrative Templates, System, and all the way down to Removable Storage Access. So on the right, I have all of the individual group policy settings related to removable storage access, such as, for example, removable disks, deny read access. Well, if I do that, that means people can't plug in removable drives. And in some networks, you might legitimately need that. But let's say we don't. There's no need for that in our environment, as an example. So I want to deny read access. I'm going to enable that group policy setting. Done. I can also deny write access. Basically, nobody's using removable media that they plug in. It's just not going to work. And that's okay in your specific environment. You've just solved that problem. So in this case, this is a standalone server. That setting is in effect immediately just for this one server, but it is a good security setting to consider. Now, moving on a little bit, how else can we secure hardware? Applying firmware updates. This would mean for routers, for switches, even for smartphones, laptops, desktops, servers, printers on the network. All of these have firmware chips, and sometimes the vendor will provide patches that fix security holes. It's important that someone track the version of firmware we have in all of our devices, and someone track if there are updates that should be applied. The other thing to think about is a USB data blocker. It's another hardware type of security consideration. Now, what is that? Well, you know how you can plug in, for example, a smartphone, a tablet, or something to charge with a USB cable. Okay, well, if you go to a public kiosk type of location, like in an airport, often they have USB charging stations where many travelers can plug in their devices. But there are some known attacks where you can actually infect devices from a USB cable. It actually has malware in the cable, in the firmware that's part of the cable, that can actually be injected when you plug a device into it. That sounds scary. That's called a USB Ninja cable, by the way. Look it up if you find that interesting. It's absolutely frightening. But what can we do about it? We can use a USB data blocker. What that means is, look, I have a device that's I use when I plug in my smartphone, my tablet for charging, that will only allow powering, recharging, only power, but not data to be transmitted through that USB connection. That's a USB data blocker. So something else to think about using at the hardware level. So it prevents data transfer through USB when you're plugging something in only to charge. Another aspect of hardware security is TPM, Trusted Platform Module. This is either burned into the motherboard of a computer or it's an add-on card you can add. So the idea is that TPM can be configured at the hardware level to check the boot integrity of your machine, such as, has the boot order changed for any devices that we can boot from? Because that could be a security risk if someone's trying to boot from USB to crack passwords on a local device. Boot integrity also means it can be used to check the integrity of OS files, checking the hash of each file to make sure it matches what's known from a vendor. Because if we have a standard Windows OS file, we know the hash value, but this checks it and it's a different hash value, that's probably a malicious file that's been planted. And so TPM can pick that up too. That's all called measured boot and boot attestation. Also, TPM can store cryptographic keys, and it can also be involved in encrypting and decrypting disk volumes. So there are software tools that use this, like Microsoft BitLocker. You can opt to configure BitLocker to store keys in the TPM. That means if someone were to physically take a disk out of a computer that's encrypted with BitLocker using a TPM, when they plug it into their computer, when they plug the disk they've stolen into their computer has a different TPM chip. It's not going to have the keys to decrypt it. They don't get access. So yet another reason, another compelling reason to enable protection for data at rest, encryption. Other considerations. What if we have a failed machine in terms of it will not boot? What does that indicate? What could cause a machine not to boot up? Well, it could be something like corrupt files. That happens. If you have a corrupt operating system file, it might not boot up correctly. But the question is, what caused that? It could be a denial of service attack, could be a malicious user. Or maybe it's malware. We've got malware that's infected the boot sector in a disk, it no longer boots. Again, why would someone do that? Don't they want to steal my money? Well, that's part of the motivation, but sometimes people just want to crash machines and prevent them from working for whatever reason, for bragging rights, or because they want to make a political statement of some kind. Who knows? But there are a lot of reasons. We might have failed disks. There might be a misconfiguration, such as with a hardware RAID controller. So to remediate machines that can't boot properly, ideally what you would do is boot through alternative media, like a DVD, a rescue DVD, or a USB thumb drive. Now, at the same time, you should prevent that from happening without entering a password. So that if you need to boot off of a USB stick, because your server won't start, you probably should have to enter in some kind of a passcode before you can even do that. So those are a couple of other options to think about. At the hardware level, for availability, we've talked about RAID. That's an important part of having redundancy of data when you use levels like RAID 1, disk mirroring. You can use NIC teaming, having multiple network cards in a host working together. So if one fails, the other one can kick in. You can also use uninterruptible power supplies, or a UPS. This means that our servers and other equipment, like infrastructure routers, switches, network printers, can be plugged into a UPS battery pack so that if the power goes out, at least those devices can stay up for a short period of time and shut themselves down gracefully. So it's for power outages. We might also have a power distribution unit, or a PDU, which means that on a rack of equipment in a server room, we can control where different devices are getting their power. As an example, modern servers in a server room will have dual power supplies, each of which can be plugged into a different power distribution unit, or PDU. So we've got multiple levels of redundancy in that case. In cloud computing, redundancy, having multiple network connections to the cloud, so if one fails, we still get to it. Load balancing, which we'll talk about later for application high availability. Replicating data across regions for data redundancy in the cloud. So there are a number of different things that we can do then at the hardware level to make sure our environments perform well and they're highly available.